Hi, everyone. Thank you so much for joining us for Engineering a Healthier and Cleaner World. Welcome to our presentation, and thank you so much for your interest in the Schulich School of Engineering. I'd like to take this opportunity to acknowledge that the University of Calgary sits on the traditional territories of the people of the Treaty 7 region in southern Alberta. The City of Calgary is also home to Métis Nation of Alberta Region 3. In this session, you'll discover how you can develop a career making a difference in the world through engineering. We'll share details about how our brand new Biomedical Engineering program will happen. We'll tell you about our Bioengineering Summer Institute and how it prepares you for your first year of engineering. And you'll discover the many ways you can study environmental and sustainability engineering at the University of Calgary. At this point, it is my pleasure to introduce our panelists. First, I would like to welcome Brianna Boris. She's a PhD candidate in biomedical engineering at the university, and she's been with Schulich throughout her engineering education. Next, we have Michael Callis. He is the director of the BME Calgary initiative at the University of Calgary and professor of chemical and petroleum engineering at Schulich. Thank you so much, Michael and Brianna, for joining us.
Thank you.
Thanks. Hi, everyone. My name is Brianna. If you were in our last session, I'm back again. Thank you so much for joining us. As Nicole just mentioned, I've been with the Schulich School of Engineering for a while now. I graduated with a chemical engineering degree and a biomedical engineering minor back in 2016. And I'm now completing my doctoral degree in the field of biomedical engineering. My work is all in designing tools and protocols for the large-scale expansion of stem cells, which are to be used for clinical trials and manufacturing. I'm actually currently over in sunny California, where I'm completing a graduate student internship, working for a bioprocess engineering company, continuing my stem cell work here.
And I'll just tell you a little bit more about myself as well. So I am a professor and my home is in chemical and petroleum engineering, but my heart is in biomedical engineering. So my research is in biomedical engineering, and actually Brianna is my PhD student. And one of my other hats is coordinating the biomedical engineering research across campus. So this research is not just happening in engineering, but also in kinesiology and medicine and nursing and science and veterinary medicine. And so you'll learn a little bit more about those things as we kind of flip through the slides. So Brianna, I think you're up next.
Mm-hmm.
Do you want me to click it? There we go.
Oh, there we go. Okay, awesome. Again, just before we jump right into telling you all about our biomedical engineering specialization or minors and the new major, we're going to give you a little bit of an overview on engineering at the Schulich School. So some of the main things and the main reasons why you might want to come here. Again, we're looking at our engineering education, work experience, co-curricular, and dedication to mental health. So applications for the Schulich School of Engineering are actually open right now. So as of October 1st, you can apply for early admission. We do encourage you to do that. We have a great educational experience program right now where we're taking our classes and we've put them virtual. So they're all online. So you can study these courses from anywhere your home is. Throughout your engineering experience here, you'll get a variety of work experiences. These come in terms of first and second year practicums over your summertime, as well as internships after your third year. We have a variety of co-curricular activities that you can take part in. So you'll kind of hear again and again throughout today that engineers, we are the problem solvers. Engineering is your applied sciences. So everything you do in the class, we right away take it and we apply it, whether that be through laboratories, whether that be through volunteer, extracurricular, or work experiences. So we have over 80 engineering clubs on campus, and these come in everything from student government to volunteering with things like Engineers Without Borders, Project 90, Women in Science Engineering, to all of our awesome competition teams. So we build solar cars, we build race cars, we build motorcycles, we build airplanes, and we race those around the world. And right from first year, you get to be involved with those experiences. And then finally, I just want to highlight our dedication to mental health. throughout this and all these exciting things you're going to hear, you're going to say, wow, is engineering really hard? And to that, we're going to say, yeah, engineering can be a challenge, but throughout your engineering experiences, we're going to be there to support you both physically and mentally. So we have a great new mental health decompression zone in our brand new engineering buildings, where you'll have access to everything from resources and workshops to pet therapy to yoga and exercise classes. So those are just some of the awesome reasons that we want to come to the Schulich School of Engineering. All right. So what do your first years in getting into your majors look like? So one of the greatest parts about the Schulich School of Engineering is every student takes a common core first year. So what that means is all our engineering students come in and they take the same 10 classes in their first year. And these are your basic introduction to maths and sciences, as well as an introduction to some of these engineering majors. So you're going to take, for example, an introduction to chemical engineering course, an introduction to electrical engineering course. This is really awesome for a couple of reasons. First of all, you're going to kind of get this broad overview of how all the engineerings work and they work together. But it's also going to give you this opportunity to find out what you really like and what you're really good at, so that at the end of your first year, you can choose which major you want to be in. So if you were like me, when I started going to school, I didn't even know really what engineering was, never mind which major that I wanted to go into. In fact, I thought, hey, maybe I'll do mechanical engineering and do that biomedical engineering minor and do things like prosthetics, because I thought it was really cool. Obviously, I still think it's really cool, but when I went into first year engineering and took that introduction to mechanical engineering class, I actually wasn't very good at it. But I took this introduction to chemical engineering class and I was really good at it and really liked it. So that gave me the opportunity after first year to choose chemical engineering as my major. So these are all the majors that you'll have an option of choosing from. We have our biomedical engineering major. I'm not going to say too much about that now because that's what the rest of the presentation is going to be about. Then just as a very high level overview, we have chemical engineering. So that's what both myself and Dr. Kalos are. And this is a very broad field where we design processes to turn raw materials into useful products. And you can do this in everything from our oil and gas industry to pharmaceuticals to cosmetics, agriculture, or your food and beverage industries. Those are processes designed by chemical engineers. Geomatic engineering is one of the fastest growing information sciences. So this is where you think GPS, if any of you played Pokemon Go, big data, that's all geomatics engineering. And the University of Calgary actually has one of the best geomatics engineering programs in all of Canada. When we think about software engineering, everyone knows this is very in high demand right now. All our companies are looking for tech talent, and software engineers from the University of Calgary are very highly hireable. Mechanical engineering, I'm going to jump there. That encompasses everything from robotics to artificial joints to designing new cutting edge buildings and vehicles. So if you like to design and you like to build things, mechanical engineering might be for you. Civil engineering, again, building. One thing that you might not be aware of is it has a lot to do with building smarter and more environmentally friendly communities. So this is everything from redesigning the transit to the water systems, building smarter, safer buildings and bridges. Electrical engineering, of course, it's creating new technologies through the manipulation of electricity. One thing that the University of Calgary actually focuses a lot is finding ways to harness new sustainable energy, and that's through electrical engineering. Oil and gas, that really prepares you to work in the energy sector, which is huge in Calgary. One last thing that I do have to mention is our dual degree program. This is for anyone who's really interested in both engineering as well as business. This program is quite unique to the University of Calgary. You can get a dual major, so no minors, a major in engineering and a major in business, in as little as 5 years. So this is really cutting down the time. Usually that would take at least 8 years, and you'll be receiving support from both the Schulich School of Engineering as well as the Haskayne School of Business. So that's just kind of a broad overview of all the different majors that you can take at the Schulich School of Engineering. Now, biomedical engineering, like Mike's mentioned, this is where both of our hearts are at, helping human and animal health through different kinds of technologies. So back in 2015, the University of Calgary launched its biomedical engineering research strategy called Engineering Solutions for Health. And this has to be the most interdisciplinary faculty on campus. We include everything from engineering, medicine, vet med, sciences, nursing, kinesiology, and we're all there working together to come up with the best solutions to some of the major health problems around the world. So there are some things you can learn about. For me, this really depends on what kind of engineer you are, what kind of fields you can get into. So if you're a chemical engineer, you're going to be focusing on things like regenerative medicine, pharmaceuticals, tissue engineering, bioprocessing. Those are all kind of cool things that I get to work on. Our mechanical engineers, they get to work on everything from device design. So right when you think of like a wheelchair, to studying the human body in motion. We have lots of awesome contracts with companies like Adidas, Garmin, you name it. If you're in the software, electrical engineering field, you're going to be focusing on everything from imaging. So how we build our MRIs, our CAT scans, our X-ray machines, to all kinds of little sensors. These include little sensors that are in your Garmin and your Apple Watches, the sensors that we use for very precise measurements in the human body when we're looking at taking glucose measurements for people with diabetes, or when we're looking at controlling all those electrical impulses in our body. So of course, the pacemaker is one of Canada's top 5 engineering inventions. And of course, it includes engineering as well as medicine. So the fields and the opportunities within biomedical engineering are really just endless. Come on. All right. So we've told you a little bit about what biomedical engineering is and hopefully kind of excited you about this field of engineering you might not have even known existed. One other thing we want to mention is this unique entrance pathway into the University of Calgary Schulich School of Engineering. The Bioengineering Summer Institute is meant for students who have taken Biology 30, but who have not completed Physics 30. So usually you require 5 courses to get into engineering, and these are your Math 30, Math 31, English 30, Chemistry 30, and Physics 30. But we realize in grade 12 that not all of you have taken all 3 sciences, and maybe you took Biology 30 instead of Physics 30. The Bioengineering Summer Institute allows you to apply with that Biology 30 mark instead of a Physics 30 mark. And you're going to come to our University of Calgary for a 4-week course in August, where we're going to catch you up and teach you all the physics that you'll need to know to enter first-year engineering with everyone else, without needing to require any additional upgrading courses outside the university. What's really cool is we're going to teach all of this physics to you through a bioengineering perspective. So there's a lot of kind of hands-on opportunities, a lot of learning about the human body. We have a lot of great guest speakers coming in, including some of the Schulich School of Engineering's past Olympian and Olympic medal winners. So we often bring in Alex Goff, who's an Olympic luge champion, and she'll tell you about how she used physics and how she used engineering to train her body to help her succeed as an athlete. So this is a very cool opportunity if you are interested in engineering, and especially if you're interested in the biomedical field and the bioengineering programs. It's a way for you to get in.
I just had to unmute myself. Thank you, Brianna. So I'm going to tell you a little bit more about our biomedical engineering major. So this is our newest program in the Schulich School of Engineering, and we will be only starting to offer it in 2021, so next fall. And so this is a really unique program. We have spent some time developing the program in consultation with industry and looking at all sorts of other biomedical engineering programs that have been going on in Canada and the US and around the world. And we really think we've come up with a great program that is a really modern biomedical engineering program. And we are taking the best of all the different departments that have offered biomedical engineering parts for the minor and putting them together into a brand new degree. And one of the cool things about this is a design spine that will go throughout the program from second year, where they do the students will do some small group projects, to third year, where they'll have 2 courses that span the entire year, working together in teams, solving problems from these other faculties that we've mentioned, vet med and nursing and medicine and all those kind of things, and ending up with the capstone design project, which all of the engineering programs do in their 4th year. This is a year-long team design project. But the biomedical engineering students are really going to have these multidisciplinary cutting edge type problems. And so we think that this program will really prepare students to work in a number of different industries associated with health and engineering. And so I've also been told to remind you, if you want to ask questions, you don't have to save them to the end. There's a little QR code in the corner, or go to slido.com #engineering, and you can ask your questions along the way, and then we'll be able to answer them at the end about biomedical engineering or any of the other things that you've heard about. So biomedical engineering major, you get a full degree in biomedical engineering. We also are still offering the minor. So if you'd like to have a core degree in another discipline, and the 6 that we offer it with are shown there. So a full degree in electrical engineering, with a bit more training in biomedical engineering, you might want to go after the minor. And so you would apply to this program and the major, along with all the other programs, at the end of your 1st year. So as Brianna mentioned, all the students do a common core 1st year, gives you a chance to learn about all the different majors and minors and programs, talk to students, talk to profs. At the end of that 1st year, you pick your program, you pick your major, and if you want to, you can pick your minor. And there's a few different minors that I'm going to talk about today, and there's more on the website if you want to learn about more of those. So these are the 6 majors that you can do the biomed minor with. And so if you're interested in keeping kind of your core discipline, one of the traditional engineering, but you're interested in applying that in a health way, the minor might be a way for you to do that. Another minor that we're very proud of, the first of its kind in Canada, is the minor in energy and environment. And this really teaches you how to assess, avoid, or minimize environmental impacts of major projects. And again, because it's a minor, you're applying this through a chemical engineering lens or mechanical engineering or electrical engineering, and you're really thinking about how do we look at the environment when we're doing all of the things that we're doing in engineering, and how do we make sure we're having a minimal impact or benefit on our surrounding environment. And so if you really want to learn about how to protect the environment and how to make sure that we're meeting the energy needs of the future at the same time, then this is really the program for you. And so some of our students have been very successful in this program. I think it's a really great program that is, again, unique in Canada. And I think Calgary is a really great place to do this, with all of our connections to the energy industry and other industries in Calgary and Alberta. We're also very proud of our efforts in sustainability. So this is another major theme that you'll see a lot of in the news. Lots of our majors really are incorporating this theme into their core programs. So it's not something that just a few students will get exposed to, but a lot of the students in the program are going to get exposed to this. Civil and chemical engineering are noted there because they are involved in major projects and major energy things. They're really leading the effort to incorporate sustainability, but a number of other programs as well. And so some research in sustainability includes things like sustainable processes for recovery of oil and gas underground, analysis on a systems level of energy systems for investment and management, converting CO2 to fuels, remediating hydrocarbon contaminated sites, and many, many, many more. So again, this is a theme that you're going to see throughout the different programs, probably more in the energy and environment minor, but also within the majors. Another thing that is really exciting, and if you have a chance, even when you're in 1st year, to come and see this once we're back in person, is the Capstone Design Fair. So we have our students in all the engineering programs work together in teams. So there will be chemical engineering teams, there'll be mechanical engineering teams, there'll also be teams that are between departments. and they they'd work on a capstone design project for the whole of their final year. And so this is a major design project where you get a topic or a challenge, and you work together as a team to come up with a solution, do some detailed design and economics, and in some cases build a prototype of that device or anything. So this is really where you apply pretty much everything you've learned over your 4 years. And if you've done internship or summer work terms, all of that knowledge comes to play in this project. And so the design fair is held in April, where all the different departments come together to showcase all of these designs. And we have people come from industry and downtown to judge from across campus. Your parents can come and see your projects. So this is really a fantastic way to show all the things you've learned over your 4 years. And this design fair has grown every year that they've done it, and it's that we've done it. Sorry, and it is really, really, really super exciting. And so if you're in first or second year, you can go and visit these and talk to the students and get an idea of what all those other programs are about and what type of things you might be interested in. And I think I'm going to hand it over to Brianna for this slide.
Awesome. Yes, this is where we just want to highlight. Of course, we do have to address the elephant in the room. We are not offering global experiences right this second, of course, due to our pandemic. But as soon as it's safe to do so again, we will be offering a variety of global learning experiences where you can travel both across Canada and across the world to attend different conferences, different volunteer opportunities, different internships, and different study abroads. So these are some of the volunteer and study abroad opportunities that our students had, particularly regarding sustainability efforts. So we had students travel to Morocco, where they were integrated into the local community and studied their wind turbines. We sent a group of students and staff over to Indonesia, where they installed a variety of spring water pipelines. And just recently, we sent a group of students to Guatemala, where they worked on designing local water filtration systems, helping the communities come up with better data management, and installing safer stoves for everyone. One thing that's really important to notice is we talk about all these awesome travel experiences. The Schulich School of Engineering is unique in having something called the Schulich Student Activities Fund. And this is a large group sum of money that's set aside every year to give to our students to help them go on these trips. So we don't ever want money kind of to be the detrimental factor on you taking one of these amazing global learning experiences. So actually all 3 of these trips, they were capped at a spending of $750 to students. So it allowed as many students as possible to take on these great opportunities. Student research opportunities. This is something that really excites me. Back in my second year of my undergrad, I approached this really cool professor named Dr. Michael Kalos, and I said, can I come work in your lab this summer? And I was very lucky enough that he said, why do you want to do this? What are you interested in? And I said, well, I think your stem cell research sounds awesome. Can you come and integrate me into that? And I did, and I got to apply for these awards. And as you can see there in the picture, we have profs and graduate students who will take you right from your undergrad and integrate you into these real engineering projects. This is kind of where I first really fell in love with biomedical engineering and kind of set up my whole career trajectory. When I came in as a second-year undergrad working for one of these research opportunities, I got to work with stem cells that came from the skin, and we are actually using them in conjunction with split thickness skin grafts to help heal burn patients. I thought this was a really cool project. I got to do a lot of hands-on work right away, and it really sold me on the research aspect. So this is, of course, something that we encourage all of our students to partake in if they want. You have opportunities to do it as part of a practicum after your first or your second year of engineering. You have those 4 months off for spring and summer where you can take these research opportunities. And then, of course, there's a bunch of international internships that are involved with research. So even what I'm doing right now, I'm working for a company in California in their research department. So biomedical engineering, of course, it's solving new problems. So a lot of companies have big research, big bioprocess departments where you can work and get more hands-on experience. Success of our graduates, we just kind of wanted to highlight some of our amazing students who have gone through either the biomedical engineering or some of the sustainability programs and what amazing success they've had. Here we have Manpreet. This is her picture on the right-hand side. I had the pleasure of TAing her in many of her biomedical engineering minor courses. She's awesome. She's now a Rhodes Scholar. Throughout her degree, she had the biggest in-depth experience of leadership. She worked with WISE. She worked with Engineers Without Borders. She had an awesome internship at Garmin. So for those of you who don't know, Garmin is an awesome company that makes really cool wristbands and watches that monitor all sorts of things. And they actually just opened their head office in a place called Cochrane, which is just outside of Calgary. So many of our biomedical engineering students can have the opportunity to do internships there, which is very cool. So she is now doing a Doctor of Philosophy actually in computer science up in Oxford. James is another awesome student. I actually had the opportunity to graduate with James. He is also a Rhodes Scholar. He did his degree in mechanical engineering, and I did a lot of work with him in Engineers Without Borders, where he was the co-president, and he spent a lot of time in Africa helping them redesign their water sustainability projects, which is now actually what he's completing his master's in the University of Oxford. So these are just some of our students, and really what we just want to show you is when you come in as a student and you go through, we're going to give you every opportunity to take part in things outside of school, whether that be through engineering work experiences, so going and volunteering and being part of clubs, and this will really set you up to do whatever you want as your next stage in your career.
Okay, thanks, Brianna. And this is the final slide with just some key dates. So undergraduate applications opened up this week on October 1st. But if you want to apply for awards, the Prestige Awards applications are due on December 1st, and then the further documents are due on the 15th. So you can apply at any time before the deadline. And if you want to be eligible for those awards, I really urge you to apply as soon as you can. As you receive your grades for this term, they will be updated in the system and the university will get the latest grades. Your fall admission applications are due March 1st next year, and your transcripts are due on the 15th. And then you will get an admission offer from the university, and you have to accept that by May 1st. So with that, I think that's our last slide. Again, if you have questions, slido.com, or there's an email there, discoverengineering@ucalgary.ca, to speak to some of our students. And I'm going to hand it off to whoever's going to help us moderate the questions. If that's Nicole or Tyler.
Hi, yes, thank you so much. I'm just going to share my screen here so that you can see what's going on with, there we go. Okay, can everybody see the questions?
Yes.
Okay, great. So we have a question here about majoring in mechanical engineering and minoring in biomedical, and about the early admission deadline. Can you speak to that?
So yes, you can major in mechanical engineering and minor in biomedical, and someone else can answer the early admission question.
Early admission is open right now, so they opened October 1st. So like Dr. Callis is saying, you can submit your application right now, and we're going to start looking at those applications as soon as possible to see if we can accept you for early admission.
And just a quick extension of that, Brianna, December 15th will be the cutoff for them to submit for early offers.
Okay, thank you. So the common first year cover biomedical engineering. So there aren't currently any courses in first year that are specifically biomedical engineering, but each of the programs has a number of presentations and opportunities to talk to students and professors about the majors. So you will have a lot of opportunities to gather more information in order to make a good informed decision about which program you'd like to go into.
Looks like this person isn't necessarily a morning person. They're wondering what time classes start in the morning.
Brianna?
Usually 8 a.m. Calgary time, Pacific.
Yep.
or Mountain Standard Time, sorry. I'm Pacific right now. So
Okay.
yeah, they do start early. To be noted, your classes are much more broken up than in high school, things like that. You don't have as many classes, but you have different labs and tutorials throughout the day.
And I think this is maybe somebody seeking some clarification about how people select their major. Can you tell us a little bit more about the common first year and then how people get into their majors?
Yeah, sure. So basically in your first year of engineering, you will just apply when you're doing early admission or general admission for engineering. Once you are admitted there, actually, it's a very easy process for you. You don't select any of your classes. You will be placed into all 10 courses, the same 10 courses that everyone takes. These will be your introductions to maths and sciences and introductions to kind of the different majors. And then nearing the end of your first year, every student will rank and select which major that they want to enter into. So yes, everyone in their first year will just be doing general engineering. At the end of your first year, you will select any majors and minors you'd like to be considered for. And as of second year, you will have an engineering major.
With regard to the different majors, are there any majors that you can take that don't allow you to take a minor in biomedical engineering?
I think oil and gas is the only one that does not allow you to take that.
Okay. And I think we answered this one already. Tell us a little bit about overseas internships. Brianna and Mike, do you know of a ton of students that go overseas, or how common is that?
It's definitely very common. So we have a very good relationship with a bunch of companies in Switzerland. We offer about 24 internships there every year, but we've also had internships around the world. We've had them in Germany and Japan, companies like BMW and Tesla. Of course, California has kind of become a biotech hub. So we have a number of companies that you can work with over here in the biomedical field. So international internships absolutely are common if there's something that you're interested in.
And the university will have job postings at the Engineering Student Center, Engineering Career Center, but you are also able to, if you find some other jobs, you can contact the office and get those and make sure that they would count as part of your internship. So you're not necessarily limited by the opportunities posted there, although there are a lot of them. If you find something else as well or learn of something else, if that's even better, you can find something of your own interest.
Okay, fantastic. And tell us a little bit more about how students can get into undergraduate research. Brianna, you mentioned that you did it, but what kind of process is involved besides just going up to a professor and saying, hey, I love your work?
Yeah, that's a great question. And we do give you a lot of resources in your first and second year. It's not like something we just expect you to kind of know as a possibility. So throughout both your classes, as well as many times throughout the year, students run different kind of networking, how to meet prof sessions that all students will be invited to. And we really kind of walk you through the process. We're going to tell you what time of year you should start approaching profs, how you should do that, how you should go to their websites, really make sure that they're in their area of research is what you're interested in. You're always able to talk to the graduate students in their lab, really see if that's something that you want to do. But it is something we're going to help you through in first year because, of course, there's a number of funding applications that we like you to apply for. And both the professors as well as older students will run different sessions for all incoming students on how you're going to be able to do that. So it's really just attention in class and the different opportunities.
Yeah, that's a great explanation. And the timing is usually if you're talking to professors about opportunities in the late fall, so November/December, the applications that we have to do for funding to get you scholarships to do this are in kind of the end of January, early February to start work that summer in May. So don't wait till April to figure out if you want to do some student research because that limits the opportunities. If you're thinking you might want to do it, start talking to people in November and December. And then when you come back from holidays in January, you can work with that professor to prepare those scholarship applications. And usually they're done with the supervisor. So you do have help doing those applications. And the university is working and has done a great job of getting a single application. And so there's one online process for a number of different scholarships for these summer research opportunities.
I think we'll skip over this aerospace industry question. On that, I would encourage you to go to our booth and talk to some folks about our amazing aerospace engineering minor that has now been approved.
But there is an aerospace industry in Alberta, and there are a number of companies. That's all I know. I don't know more, but I do know there are opportunities.
With regard to kind of figuring out whether biomedical or energy and environment engineering is right for you, what do you guys say in terms of who should people talk to make sure this is really the right career for them?
I'm going to suggest that during first year, each of the majors and minors has a student association, a student group. And I would urge you to go in and talk to those groups. So the Biomedical Engineering Student Society is very active. It has students from all the different departments in second, third, and fourth year. Some of them have gone in internships. They've taken some of the courses, and they can really tell you about the program and what opportunities they see. So that's one thing. You just go talk to other students that are, just a little bit more senior in years. And I think that would give you an idea. And, Brianna, if she's your TA for one of your courses, you can always go and approach her. So most of the TAs that you will have for your courses, those are the graduate students helping mark assignments or run the labs, are graduate students. So they are working, they're more senior students in a certain area, and they might have insight as well about the different fields and what opportunities there are.
When it comes to choosing your major, this must happen. Students get into their major, they decide this isn't quite right for them. How hard is it for students to move from one major to another without skipping a beat or having to add extra time onto their education?
So this really depends on which major you want to switch into and which one you're coming from. And because each of them have a specific set of courses that you need to graduate, and there are prerequisites and a certain path of those courses. So for example, if you are in chemical and you want to switch to mechanical, while some of the courses might be common between those two, there are a number that are not common. And some of those not common courses might be prerequisites for something in the next year. So in general, I don't think that a lot of students switch over majors in midstream like that. And I think the best way is to pick something that you like at the end of first year by gathering a lot of information. And don't pick something where you are thinking about the jobs, or because that's going to be 3 or 4 years later, and who knows what's going to be happening. So pick something you like. In the end, you are being trained as an engineer and a problem solver. And a lot of jobs you go out to, it'll say a chemical or mechanical engineer we want for this position, or a civil or a structural engineer. And so if you really want to know, kind of look at the industries you think you might want to work in. Go look at some of the job postings and get a feel for what type of engineering you look at. And a lot of them will be not as specific as you think. So pick something you like is my main advice.
Yeah, and just to add on to what Mike was saying, there is we really want to make sure you have something you like and what you're good at. At the end of the day, you're going to be an engineer, which means you're a problem solver, and the job you get might easily cross over into paths. So when I did my engineering internship, I actually worked for a bone company. So it was much more civil engineering as opposed to chemical engineering, but that was okay. I had that strong problem solving basis, so it wasn't a problem.
Can you tell us a little bit about what kinds of careers people can end up working in if they become biomedical engineers? Or biomedical engineering in sustainability? Is there a connection there?
So there are about 300 life sciences companies in Alberta. Probably about half of those are in the medical or health related area. So either devices or pharmaceuticals or health data, IT type things. The other half are probably in more agricultural and forestry and those kind of areas. Biomedical engineering jobs include things like Garmin that Brianna mentioned. There are other companies like Orpix, local medical device company that makes a insert for your shoe for patients with diabetes. There are a number of imaging companies that have hired a lot of our students, sorry, like Circle Cardiovascular, Kent Imaging, Calgary Scientific. So I think there are a lot of local jobs. It is a growing industry, but there's also a lot of opportunities nationally and internationally. One thing we haven't talked about is entrepreneurship, which is a big area here. So if you don't see the job you want and you're pretty excited about something, you can look at starting your own company and becoming your own boss, and then hiring all of us later on when you become the next Apple or Google or Stryker in terms of medical devices. But I think there are other sessions about that piece of the University of Calgary.
Join us for the Becoming an Engineering Entrepreneur session if that sparks your interest.
Perfect.
This also leads to the next question, Mike, talking about this being a globally viable pathway. How niche of a field is bioengineering, and what are the job opportunities around the world?
There are a lot of opportunities around the world. So this is one of the fast growing areas of engineering. So health and human and animal health is always going to be a challenge, and they're always going to need engineers in order to solve those types of problems. And there are opportunities in Canada, the US, Europe, globally. It's not a niche. It is becoming a real major on its own, and companies are really starting to recognize what a biomedical engineer is and want to hire them because they have this teamwork, they have multidisciplinary experience, they have communication skills across disciplines. These are really valuable in a lot of different careers. And yes, you can go to be a career as a physician, to answer the next question. A number of our students enter into med school after doing our degree.
Yes. Do you remember if medicine is your end goal and you're trying to pick an undergrad? Most people going into medicine might think, oh, I need to do biology or health sciences, but med schools, as well as actually all other post-grad like law, pharmacy, you name it, they really, really love engineering students. And that's because we're making problem solvers, of course. So as a doctor, you're going to be put in a lot of situations where you need to solve problems. So we like, so med schools, law schools, all of them really, really appreciate engineers, especially engineers who have a biomedical background.
Taking a look at sort of some of the examples of how bioengineering has helped during COVID-19, I think this is a really great question. Mike, could you quickly talk a little bit about some of the things that happened within Schulich School of Engineering in the bioengineering realm to address this issue?
I have a half-hour presentation, but I'll do it in 10 seconds. So yes, bioengineering and biomedical engineering has definitely played a large role in the pandemic. We have had either faculty or students or spin-off companies from the university using 3D printing to make face shields, designing and producing new swabs to do testing, the things that they stick up your nose to do the testing, looking at the development of new diagnostic devices to actually do the detection a lot faster and then wirelessly transmit that data to the health system. We have also been involved in projects to make ventilators for Alberta Health Services and a number of other initiatives, including even some graduate students running some competitions around brain and mental health and COVID, and getting student teams together to make apps or design devices that will help with brain and mental health around COVID-19. So there's been a lot of activity actually involving engineering faculty members and engineering students to assist with this pandemic.
Taking a look at the specific majors that people might want to choose if they're planning on becoming an environmental engineer, what would you recommend?
You have opportunity with almost all of the majors. The ones we highlight are often chemical engineering because it focuses a lot on energy and getting sustainable energy from different sources, as well as civil engineering. There's a lot of opportunities not only with community design and rehabilitation, but also building these, you hear, smarter bridges and smarter buildings. So if you do have the opportunity to come to the University of Calgary and look at all of our buildings, many of them are made by civil engineers who work on something, a global standard called LEED certification. And it's finding different ways to make the buildings as environmentally friendly as possible. Lots of our buildings, we collect all the rainwater. We have water coolers underneath to do kind of a geothermal heating system. We collect all the beautiful sunlight that we have in Calgary to do a lot of natural light. You name it, our buildings are kind of a world state of the art in terms of environmental and sustainability. But that being said, obviously, with other degrees like mechanical engineering, there is potential to work in that environmental sustainability field.
We have time for one more question. So I'm wondering if you could tell us a little bit about the minors that are available for people who study biomedical engineering.
So right now we are focused on just launching the program. So currently there aren't other minors that can be taken with biomed. It is something we would like to expand in the future. But we're focusing on getting the biomed program running, and then we will look at which minors we can add on.
So that brings us to the end of our discovery session. Brianna and Michael, thank you so much for helping us understand biomedical engineering to the extent that you have. And thank you to all of the students, potential students that joined us. If you have more questions, we would really encourage you to visit the Schulich School of Engineering's virtual booth. We have student advisors there standing by to chat with you. And further to Michael's point about the business and engineering dual degree, we have a session coming up in 15 minutes where you can learn more about the dual degree and some of our business-related minors. So that's called Becoming an Engineering Entrepreneur if you're interested. And that wraps up the session. Thank you, everyone.